Hello, welcome to your very first of many video quiz reviews. The purpose of this video is to go over all the content that's going to be on your quiz that's on Thursday this week. So it'll just be a quick review of all of that content. If you have more questions, by all means, reach out and let me know. You can talk to me during office hours. You can talk to me during a lunchtime. Anyway, this is supposed to review everything that's going to be on the quiz that we know. I sent in that Google Classroom announcement that we're going to have questions about the divisibility rules that I want to make sure that you have down and memorized. You're not going to be able to have your notes during the quiz, remember, so you're going to want to make sure you have practiced those and have those things to memory. And then vocabulary, prime, composite, factors, and factor pairs, and multiples are the things that are going to be on this quiz. I'm wanting it to be friendly. I'm wanting you to be successful. Fair warning on all of the stuff I told you last week what was going to be on this quiz. And here we go on the quiz review video. So what you're going to need to do is get out your notebooks. And you're going to be writing notes based on this lesson. I know that all of this stuff is review because we've all gone over all of this, and so it's going to be elsewhere in your journal, but it's going to be on this page as well. So you're going to put the date on the page. You're going to write your notes as you're watching the video. Pause the video if you need to. Rewind the video and go back and watch a little bit. Again, if I speak too fast or if I wasn't clear, then watch that video one more time. And I highly recommend actually that not only do you take your notes for this homework assignment, but you also maybe just rewatch that video one more time on Wednesday night before the Thursday quiz. So you're going to take notes based on this video. You're going to then take a photo of those notes and attach them in Google Classroom to the assignment where you found this video. So this is a homework assignment. So make sure that you write notes about everything that we are talking about in this video. All right, so let's get started. The first thing that's on there is about the divisibility rules. And so these are those rules that you know a number is divisible by, come on down, there we go, there we go, by 2. We have rules for 2, 3, 4, 5, 6, 9, and 10. I mean, everything is divisible by 1, right? So that we don't need to have a rule for that one. We discussed previously that if the number is even, if it's an even number, if it has a 2, 4, 6, 8, or 0 in the ones place, then you know that it is divisible by 2. The divisibility rule for 3 is if sum of the digits, try it again. If the sum of the digits is divisible by 3. All right, if the sum of the digits, please remember sum means the answer to an addition problem. So if you add all of the digits together in the number and that sum is divisible by 3, then the whole number is divisible by 3. And that lets you use a really complex, longer number and figure out if it's divisible by 3 or not by adding all the digits together and seeing if that number can be divided by 3. So for the divisibility rule for 4, look at the number formed by the ones and tens place. And so, for example, if you had, and this really is only a helpful rule if you have a larger number. So if we had the number like 1,624, all you need to look at is this number here, the ones and tens place makes the number 24. Is 24 divisible by 4? Yes, then the whole number is. All right, we might as well go back and do an example for the sum of the digits. So if the number was 181, add 1 plus 8 plus 1 is 10. and 10 is not divisible by 3 because you can't count by 3s and hit that. But 183 is 1 plus 8 plus 3. 8 plus 3 is 11, plus 1 is 12. Then it is divisible by 3 because I can count by 3s to hit 12. All right. The rule for 5, if there is a 5 or 0 in ones place. I'll write out a little bit of a 1. Ones place. The exception for that is if the number is 0. Just 0, that's not divisible by 5. But any other number that has a 0 in the ones place, like 10, 20, 30, 40, 50, and so on, those all have zeros in the ones place, then those are divisible by 5. All right. The divisibility rule for 6. If it is divisible by both 2 and 3. And I don't want to say plus. 2 and 3. So if the divisibility rule for 2 works and the divisibility rule for 3 works, then it is also divisible by 6. All right. So 6 requires a 2-step to try both of these. All right. But for our chart that we're going to be doing on the quiz, which you'll see in just a minute, that'll already be done, which would be really helpful. All right. The divisibility rule for 9. If it's just like for 3, except for if the sum of the digits is divisible by 9. Sum, meaning add, of the digits is divisible by 9. So, for example, 186, 1 plus 8 is 9, plus 6 is 15, not divisible by 9. But 387, 8 plus 7 is 15, plus 3 is 18, then it is. All right. And the divisibility rule for 10, if there's a 0 in the ones place. With the exception of the number 0. If it was 0 is the number they gave you, that's not divisible by 10. But any other number that has a 0 in the ones place, 10, 20, 30, 40, 50, and so on, is divisible by 10. All right, so that's a lot of writing. And I know some of you are not going to be like the Flash with your writing. So I'm going to ask you to pause the video, make sure you've written these notes down, and then we'll come back in just a minute. I'll give you a moment to copy down this table. And you know, you don't have to draw all the lines and columns necessarily, but I did. But we are checking to see, this is just like the homework assignment we had. There was a worksheet page 68, which you might still have in your possession. This table, some of the problems were directly from that worksheet, and then I've added a couple. There will be a table just like this on your quiz. And all you're going to be responsible for doing is going through and putting a check mark for each number that is divisible, that 28 is divisible by. Is 28 divisible by 2? Is 28 divisible by 3? Is 28 divisible by 4? So you're going to go down the line asking yourself that question and putting a check mark if it is true. Please do not actually put an X if it is not true, because then sometimes your X's and your check marks might look confusing to me. So leave it blank if the answer is no, and then put a check mark in it if the answer is Yes, it is divisible. All right. So copy this table down, or at least the numbers and the columns of 2, 3, 4, 5, 6, 9, and 10. And the numbers 28, 91, 135, 2,420, 6,192. Pause the video and do it. This is just to see if you can answer these questions on your own, and then we'll go over it on this video. All right, so pause the video right here. Try and solve these yourself. All right, let's go through. 28, is it divisible by 2? Of course it is, because it's an even number. 28, is it divisible by 3? Well, 8 plus 2 is 10. You cannot count by 3s to hit 10, so it is not. 4, remember the rule for 4 is look at what's in the 10s and 1s place. Well, that's 28. So you just have to know that math fact. It turns out that it is. 5 is not, because there's not a 0 or a 5 in the 1s place. 6 is not, because it would have to be 2 and 3 to make it 6. 9 is not, because I cannot count by 9s and hit 28, but also 8 plus 2 is 10, and that is not divisible by 9, so no. And then 10 is not, because there's not a 0 in the 1s place. All right, so only 2 and 4 in that row. 91, it is not divisible by 2 because it's an odd number. 9 plus 1 is 10, not divisible by 3. 91, also again, it's got a 1 in 10's place. There's no larger number here. But I do know another rule that I didn't write down on that other thing, but every multiple of 4 is going to be an even number. When you count by 4s, 4, 8, 12, 16, they're all even. You're never going to land on an odd number for 4. All right? 5, nope, there's not a 5 or a 1, a 0 in the 1's place. 6, nope, because not 2 or 3. 9, no. Add the digits, 9 plus 1 is 10. Can't count by 9s to hit 10. And 10, no, because there's not a 0 in the 1's place. So nothing gets checked in that row, and that's fine, because none of them are divisible by, 91's not divisible by any of those numbers. All right, 135, no, for 2, because it's an even number, and this is odd. 3, 1 plus 3 is 4. 4 plus 5 is 9. Can I count by 3s to hit 9? Yes. 35 for 4, looking at the 1s and 10s place. Nope, because I can't count by 4s and hit 35. Remember, 4 isn't going to give me only even number multiples. All right. 6, no, because it's not 2 and 3. It has to be both of these in order for 6 to work. 9, what was that again? 8, 5 plus 3 is 8 plus 1 is 9. Can I count by 9s and hit 9? Yes, I can. And 10, nope, there's not a 0 in that 1's place. There's not a lot of check marks here going on. All right, now we jump to the big leagues, to this bigger number, 2,420, which is really why these divisibility rules are helpful. All right, is it even? Yes. Can I count by 3s to get there? Well, let's see. 2 plus 4 is 6, 7, 8, plus 0. Nope, can't count by 3s to hit 8. 4, I'm going to look at the 1s and 10s place. There's a 20, so yes. 5, 0 in the 1s place, yes. 6, no, because it has to be 2 and 3 in order to be divisible by 6. Nope. What did we get? 4 plus 2 is 8. Nope, can't count by 9s to get to 8. But I do have a 0 in the 1's place. So that makes it divisible by 10. All right. Then we have another bigger, even bigger number, 6,192. Well, it's even. So we know it goes in there. 6 plus 1 is 7. 7 plus 9 is 16. 17, 18. So the sum of the digits is 18. Can I count by 3s to get to 18? Yes, I can. Is 4 going to work? Well, let's take a look at 92. Boy, you know, I'll tell you, this is going to be one of those places. I'm going to write down here for a second. 92. Remember, there was a time, maybe it was last week, and I started talking about something that's called decomposition of number, where you're pulling the number apart dividing its pieces, and then putting the answer back together. So it's easier for 92 for me to think about it, and we're talking about 4s. We're trying to see does 4 go into 92? Maybe it's helpful for me to think about it as a 40 plus a 40 plus a 12. 40 plus 40 is 80. 80 plus 12 is 92. I can count by 4s to hit 40. I can count by 4s to hit this 40. I can count by 4s to hit that 12. So that means I can count by 4s to hit the whole thing. If I did the division problem here, 4 goes into 9 twice. 2 times 4 is 8. Subtract, and I have 12. So it goes in 23 times. And we know, how many times does 4 go into 10? It goes in 10 times. How many times does 4 go into this? 40. 10 times. How many times does 4 goes into the 12? 3 times. There's that sum that gave us 23. All right, so in other words, yes, 4 goes into 92. I know that for a lot of folks, division like this is still like, but you can probably think about 92 as splitting it into those friendly numbers, right? We've talked about friendly numbers a lot recently. All right, so we know 2 is yes, 3 is yes, 4 is yes, 5, no, 6, 2 and 3 are yes, so 6 is yes, 9. What did we get for our sum of the digits again? 6 plus 1 is 7, 7 plus 9 is 16, 17, 18. Yep, that'll work. 18, okay. And then there's not a 0 in the ones place, so no. All right, so there you go. How'd you do? I'm hoping that you did well on that chart. But something like this, it's not gonna be these exact numbers, but something like this will appear on that quiz. And so, yeah. All right, let's do one more. Actually, you know what? I'm gonna leave that on there. What I would ask that you do on your notes, if you made errors, put a circle around the ones that maybe you forgot to put some check marks in, like you checked off some of them, but not all of them. Put a circle around the ones to remind yourself what went wrong so that you can work on that piece of it, right, as a reminder. And if there's check marks that you shouldn't have put on there, then maybe you draw a little X through it, like, oh, I put a check mark here, but I really shouldn't have. That's also a learning experience, and that's okay, all right? All right, let's move it along. I have one more set of vocab for us to go over, and then a couple more sample problems, and then we're gonna be done. And I know that this video is rolling a little bit long, and that's okay, because it's just one homework assignment. We don't have these every night. So I wanna make sure that we cover all of this content to make sure that you're really prepared for that quiz. So thank you for sticking with us right now, all right? So vocabulary, there will be some kind of component of the quiz where there's a vocabulary matching, where I'll give you some definitions, and you're gonna have to match the vocabulary to its meaning, all right? So the definitions I wanna make sure that you understand are prime, composite, factors, and factor pairs, and they're related, so I kind of put them on the same line, and multiples, all right? So prime numbers are numbers that have exactly 2 factors, right? So what are factors? Factors are like those ingredients that when you're multiplying numbers together, those numbers that get multiplied are the factors, all right? So it's almost actually easier for me to use an example for that definition. So if I were to say 4 times 5 equals 20, these are the factors. 5 and 4 are the factors. They're the numbers that are getting multiplied to make a product, okay? So the definition for factors, the numbers being multiplied to make a product. And I want you to remember Now, just like the word sum means the answer to an addition problem, the word product here is the answer to a multiplication problem. Okay, so if 4 and 5 are the factors, 20 is the product. All right. So then if I were making my list of all of my factor pairs of 20, I would list 1 times 20 as a factor pair of 20. I would list 2 times 10 as a factor pair for 20. And 4 times 5 as a factor pair for 20. And remember that commutative property of multiplication says that I can change the order. So 5 times 4 is also a factor pair for 20. And 10 times 2 is a factor pair for 20. And 20 times 1. But I don't need to necessarily list all of them if they're inverse, if their commutative property pair is present. All right. So factors and factor pairs. So here is our factor pairs. Right? And here's our factors, and there's our product. Here's our vocabulary definition. Okay? Composite numbers. Numbers that have more than 2 factors. Come on now. Here we go. Numbers that have more than 2 factors are composite numbers. The only number that has less than 2 factors is 1. But any other number is either going to be prime or composite. Either they're going to have 2 factors only, like 5 or 7 or 13 or 17, right? Only have 2 factors. 1 times 17 is 17. That's the only way to multiply to get 17 is by multiplying 1 and 17. So to keep in mind, actually, one factor is 1. Other factor is itself, right? So for 17, it's 1 and 17 are the only factor pairs for 17, all right? Composite numbers have more than 2 factors, like 20. It has 1, 2, 3, 4, 5, 6 factors, right? All right, and then multiples are counting by a number, right? Counting by a number. So if I were giving you 6, the multiples of 6 might be 6. Here, I'll write them horizontally. I don't know why I was doing that. 6, 12, 18, 24. If I'm counting by 6s, 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, right? So I can see on the quiz asking you to, giving you a number like 20 and saying name all the factor pairs, because there's a finite number of them. There's a limited number of factor pairs for every given number. But there's an unlimited, infinite number of multiples. Because I could keep counting by 6s until I'm an old man, too late. I'm already there. But I can keep counting by 6s and go on and on and on and on. So I could see on the quiz me saying, give me the first 5 multiples of 12. Right? What are the first 5 multiples of 12? Well, the first one is going to be 12, right? That's 12 times 1. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. That's the first 1, 2, 3, 4, 5 multiples of 12. All right. So I could see myself on a quiz giving you a number and say, tell me all the factor pairs. And I could see on that quiz me saying, show me the first 5 multiples of whatever number I give you. All right. So I think that's about all. I want to wrap it up here. So quick review one more time of what we just talked about. Divisibility rules are going to be on the quiz. Vocabulary, prime, composite, factors, factor pairs, multiples. We talked about all of our divisibility rules here. We practiced using the divisibility rules on a table just like this that'll appear on the quiz. And we talked about our vocabulary. There'll be some sort of matching element on the quiz where you have to match the vocabulary to its definition. But it also says on the study guide that I sent you in Google Classroom, it said use of those vocabulary words as well. So there will be something where I'm asking you to show me that you understand how multiples work, how factors work, right? Okay. So I hope this is helpful. I know it ran a little long. This is pretty typical of a video, so get used to that. But please let me know if you have any questions, all right? And I know you guys are going to do great. Good luck. Please check in with me if you have any questions. The quiz is on Thursday. I know you can do it. Okay, let's do this together. Yes, we can do it. Okay, bye.